morning, everyone. Welcome to my class again. This is Wanies Academy. It's always our duty. We see it as a duty, a point of responsibility to always churn out good content on sciences. So today, I'm your physics teacher, and I'll be taking you on conduction, convection, and radiation. These are methods, these are ways in which heat is transferred, the way heat is transferred. So under this lesson, we'll be looking at number one, at the end of the lesson, our lesson objectives are just three again. Be able to define and explain heat transfer method. The methods of heat transfer should be able to explain that after the lesson. Then differentiate between conduction, convection, and radiation. Then apply heat transfer concept to everyday situation. So you understand that all of the concepts in physics are applicable to our day-to-day life. So that is why physics is defined as a study of matter in relation to energy. So now look at it now. Heat transfer is a movement of thermal energy, heat energy, from a hotter object to a cooler object. So it means that before heat can be transferred from one object to the other, one must be hotter than the other. So it implies that if the two objects are of the same temperature, the same heat, the quantum of heat in the two of them are the same, then there won't be energy transfer. So we'll not talk about heat. So now there are three main ways in which heat is transferred from one object to the other. Number one, we have a method known as conduction. Number two, convection. Number three, radiation. CCR. Conduction, convection, and radiation. Method of heat transfer. Now, let's look at each of them in more details. Now, we have, when we talk about conduction, we're talking about transfer of heat through direct contact. You have two objects that are in contact with one another. Heat is transferred from a hotter one to the cooler one. Then we say that method that involves the touching of two objects is known as conduction. Now, we have the other one, which is convection. Convection is a method of heat transfer, through the movement of fluid. When we talk about fluid, we're talking about liquids and the gases. So both of them are referred to as fluid. So now, each of these methods plays an essential role in our day-to-day life, from cooking to weather patterns and even our space travel. So now let's look at them, each of them, in a more deeper way. Now look at it now. By definition, we say conduction is a process of heat transfer through a material without the movement of the material itself. So the material doesn't move, but heat is transferred when they come together. So it occurs due to collision and vibration of particles within the substance. So conduction happens as a result of collision and vibration of the particles. Every material is made up of one particle or the other. So the movement and the vibration of these particles is what gives rise to conduction as a means of heat transfer. How does it work? Let me explain how it works. When heat is applied to one end of a solid object, what happens? The particles in that region will gain energy and vibrate faster. So this particle now collide with neighboring particles. They begin to internally, you will see, they collide with one another. So now we have, this is the solid, let's say this is solid. These are the particles. Now, when heat is applied, this particle is set in motion. The particles are set in motion, and they begin to vibrate and begin to collide with one another. As they collide with one another, what happens? They are transferring energy to themselves. So now, this process, continue until the heat is spread throughout the materials. So because the energy is increased until the heat is spread throughout the material, what now happens? So where conduction occurs, mainly conduction occurs actually in solids, because the particles of solid are closely packed. They are closely packed. So now they vibrate, and in the course of that, energy is transferred within the particles. Now we have solids like metals, are the best conductors of heat due to their free electrons in metals, which carry carry heat energy efficiently. Now, non-metals and gases are poor conductors. Why? Because they don't have a mobile electron within them. So they are poor conductors. They don't have free electron. Now, example of conduction. Now, where do we experience this? A metal spoon, when you put it in a pot, before you touch it, it's already hot. Walking barefooted on a hot pavement, you feel, the hotness of the pavement. Now, cooking with a frying pan, the heat moves from the burner to the pan and then to the food. Then you say you're cooking. Now, good and poor conductors of heat of heat. These are materials that are good conductors. Materials like copper, aluminum, iron, silver, they are good conductors of heat. While poor conductors are, materials like wood, plastic, rubber, glass, and air. They are all poor conductors. Now we move straight into the second method of heat transfer, which is the convection. Convection is a transfer of heat in liquid and gas, and they are referred to as a fluid. Now, due to the movement of the heated particles, it occurs because warm fluid becomes less dense and rise, while cooler fluid becomes denser and sink. So the continuous cycle is known as conventional current or convection current. So when this happens continuously, it is referred to as convection current. Now, how does it work? How does it work? Are you getting it? Very interesting. When a fluid is heated, its particles move apart, making it less dense. Now, the warmer, less dense fluid will now rise, while the cooler, dense fluid sinks. So as the cooler fluid moves down, it gets liberated and rises, now creating a circular motion called a conventional current. One rises, the other one goes down, the other one goes up, begin to create a circular movement, in form of a circle, and that is what is referred to as conventional current. One is moving down, the other one is moving up, the other one is moving down. A circular pattern is created, known as a convection current. Now, where do we see this happening? We see it in fluid, like it's liquid, water, oil, molten lava, and in gases like air, steam, and atmosphere, in the atmosphere. Now, examples of convection. When you boiling water, heat moves from the bottom to the top of a pot. Now, sea breeze and land breeze. Warm air over land rises and cool air from the sea moves in. Then it also happens in a hot air balloon. Warm air inside the balloon rises, making it to float. Then in room heaters, hot air rises, it cools, cool air sinks, distributing heat throughout the room. So these are places where convection happens. Now, but we also experience convection in nature, like the ocean current, the weather pattern. All of those things are examples of convection in nature. Is that correct? Are you okay? Yeah, that's it. So that is about that. Then quickly, we go into the last one, radiation. What's radiation? Radiation is the heat is the transfer of heat through electromagnetic wave without the need for a medium, either solid, liquid, or gas, to touch, or you don't need it. It's just like your sun, the heat from the sun. You don't need a material medium for you to feel the heat from the sun. So this means that heat can travel through empty space, through a vacuum. How does it work? All objects emit heat energy in the form of, infrared radiation. Now, the hotter an object is, the more radiation it emits. So radiation can be absorbed, can be reflected, or can be transmitted by different surfaces. So now, where radiation occurs, where does it occur? Radiation occurs in vacuum, in empty space, in air, and other materials. So these are places where radiation occurs. Now, examples of radiation: the sun, reaching us, the sun heat reaching the earth is a good example of radiation. Feeling warm from a bonfire without touching it is an example of radiation. A microwave heating food, using electromagnetic wave is an example of radiation. A black car absorbing more heat than a white car is an example of radiation. All of these are good examples of each of these methods of heat transfer. And so now we also see that these are very important concepts that we need to know, especially when we are studying heat energy. So we are going to continue from here in our next class. In our next class, we are going to continue from here. Any question? Okay, no question. Okay, so I'll see you next week in our next class. Please watch our videos as we churn out good content, educative content on the basic subjects in the sciences. Watch and subscribe to our YouTube. Thank you.